largely going to be an update, actually, because you and Senator Levins were involved and endorsed the original start of this project at Gay. So it's a legacy project having to do with mining and discharges of mining tailings into the shoreline and their effects on Lake Superior. The Lake Superior landfill is now considered, this is one of the primary issues of concern in terms of Lake Superior. As the background, there are over 140 copper mines and 40 stamp mills that process the salt and conglomerate from the mines. And we found in our KITES project, and it has supported NOAA KITES project, that there was this halo of copper in sediments extending out 80 kilometers from Keweenaw into Lake Superior. And we suspect that that came from a fine fraction of these discharges. But our real concern right now is the larger fractions and what they're doing in some of the impacted sites. In particular, one of the most heavily impacted sites is at Gay, where 2 mills released 22.7 million tons of sandstone between 1900 and 1932 into Grand, or locally called Big Travis Bay. And you can go there, and there's 20-foot bluffs of sandstone still there. But the shoreline is eroding at about 26 feet a year, and you can see the material being carried out into Keweenaw Bay. As part of our work in collaboration with Vicksburg and with the Army Corps of Engineers of Vicksburg and Detroit, we've been able to quantify, Ms. Tech up here and Mitri down in Hanover, been able to quantify this erosion. And if you go out to Gay now, only a small fraction of the original pile is still there. All this material has been washed downstream, so there's 3 million tons less than actually on the original pile. There's over 8 million metric tons extending down to the Travis River seawall and extending over it, overtopping it right now. That makes up 11 million tons. So that's half. So where's the other half gone? And it's underwater, and it's causing threats. And it takes technical expertise to actually try and document where this material is gone, and that's tech. And what we have here is we've been using LIDAR. LIDAR stands for laser detection and ranging. And 5 times we sent planes over from 2008 to last summer. And there's 2 laser beams that come off the belly of the Cessna. One bounces off the surface of the water, the other one goes down to the bedrock and bounces back. And the difference we can map as a digital map. We also have in the plane something that picks up color bouncing back from the lake bottom. And that gives us these really elegant maps. You don't realize that they're stitched together from individual points. The millions of point making is but if you look at the bay now, you can see up there in the upper portion of the original pile. Here's the shoreline. Sand behind the shoreline, extending all the way down to the Travis River. And we picked up these moving underwater sand bars. And they're moving across the bedrock, the Jacobsville sandstone, and dumping into what we discovered was an old lake bed, ancient riverbed. And this has protected Buffalo Reef for decades. However, now, as you can see in this image, the material is mounting up and is starting to move into the breeding grounds, where eggs are dropped by lake trout and lake whitefish, boulder fields here. Buffalo Reef is one of these promontories, so it sends all the way down and around here. These are some of the fields. We use the color to try and determine for the Army Corps how much encroachment of sandstone do we have on Buffalo Reef. And outlines of Buffalo Reef are superimposed here on this image. It almost looks like a fish, which is very appropriate. And the red is the sandstone, which we pick up because they're very dark. And our estimate right now is that 35% of the area of Buffalo Reef is covered by mixed use of sandstone.